The sun is a star. It is the heart of our solar system, providing the energy necessary for life on Earth. Without the sun, our planet would be a frozen wasteland, devoid of life. The sun's energy drives our weather, fuels plant growth, and powers the solar panels that generate electricity. It is a constant presence in our lives, rising and setting each day, marking the passage of time. It is a giant ball of hot gas, primarily composed of hydrogen and helium. The sun's core is a nuclear furnace where hydrogen atoms fuse to form helium, releasing vast amounts of energy in the process. This energy radiates outward, eventually reaching Earth as sunlight. The sun's surface, known as the photosphere, is a turbulent place with constant eruptions and flares. The sun goes through cycles of activity. These cycles are driven by the sun's magnetic field, which becomes twisted and tangled over time. As the magnetic field becomes more complex, the sun's activity increases, leading to more sunspots, solar flares, and coronal mass ejections. These cycles are a natural part of the sun's behavior, and they have been observed for centuries. These cycles last about 11 years. Each cycle begins with a solar minimum, a period of low activity, and builds to a solar maximum, a period of high activity. The transition from minimum to maximum and back again is gradual, taking several years to complete. Scientists track these cycles using a variety of methods, including counting sunspots and measuring the sun's magnetic field. At the peak of each cycle, the sun reaches its solar maximum. This is when the sun is most active, with numerous sunspots and frequent solar flares. The increased activity can have significant effects on Earth, including disruptions to satellite communications and power grids. This is a time when the sun is most active. Solar flares, which are sudden bursts of energy, can release as much energy as 1 billion hydrogen bombs. These flares can send streams of charged particles toward Earth, causing geomagnetic storms and auroras. The sun's activity during solar maximum can also increase the amount of radiation in space, posing a risk to astronauts and satellites. During solar maximum, the sun has more sunspots. Sunspots are cooler, darker areas on the sun's surface, caused by intense magnetic activity. They appear dark because they are cooler than the surrounding areas, but they are still incredibly hot, with temperatures around 3,500 degrees Celsius. Sunspots are cooler, darker areas on the sun's surface. They are regions where the magnetic field is particularly strong, inhibiting the flow of hot gas from the sun's interior. This results in a lower temperature and a darker appearance. Sunspots can be many times larger than Earth, and they often appear in groups. They are caused by intense magnetic activity. The sun's magnetic field is generated by the movement of hot, electrically charged gas in its interior. This magnetic field can become twisted and tangled, creating regions of intense magnetic activity on the sun's surface. These regions are where sunspots form. Solar maximum is a time of increased energy from the sun. This increased activity can have a variety of effects on Earth and in space. For example, solar flares can disrupt radio communications and navigation systems, while coronal mass ejections can cause geomagnetic storms that affect power grids. Understanding solar maximum is important for predicting and mitigating these effects. It affects Earth and space. The sun's energy drives our climate and weather, and changes in solar activity can influence these systems. For example, periods of low solar activity have been linked to cooler temperatures on Earth, while periods of high activity can lead to warmer temperatures. The sun's activity also affects the space environment, creating hazards for astronauts and satellites. The sun's energy can disrupt satellites. Solar flares and coronal mass ejections can send streams of charged particles toward Earth, which can interfere with satellite electronics and communications. This can lead to temporary outages and, in some cases, permanent damage. Engineers design satellites to withstand these effects, but predicting and understanding solar activity is crucial for minimizing the risks. It can also cause auroras or northern lights. These beautiful displays of light are caused by charged particles from the sun interacting with Earth's magnetic field and atmosphere. The particles excite atoms in the atmosphere, causing them to emit light. Auroras are most commonly seen near the poles, where the magnetic field is strongest. Scientists study solar maximum closely. They use a variety of tools, including ground-based telescopes and space missions like the Parker Solar Probe, to observe the sun and its activity. By studying solar maximum, scientists hope to better understand the sun's behavior and its effects on Earth and space. They want to understand how it affects us. Solar activity can have a wide range of effects, from disrupting communications to influencing climate. By studying the sun, scientists can develop better models to predict solar activity and its impacts. This knowledge can help us prepare for and mitigate the effects of solar maximum. They also want to predict when it will occur. Predicting solar maximum is challenging, but advances in technology and our understanding of the sun are making it possible. Accurate predictions can help us prepare for the increased activity and its potential impacts, ensuring that we can continue to rely on the sun's energy while minimizing its risks. Predicting solar maximum is difficult. Scientists use different models and observations. Sometimes their predictions disagree. Some scientists thought solar maximum would happen in 2025, others thought it would happen later. This is because the sun is complex. Its cycles are not always predictable. Recent observations have changed our understanding. The sun has been more active than expected. This suggests that solar maximum might occur later than previously thought. It also suggests that this solar maximum might be more intense. Scientists have observed interesting things on the sun recently. They have seen more solar flares. Solar flares are sudden bursts of energy from the sun. Some of these flares have been X-class flares. These are the most powerful type of solar flare. Scientists have also seen a new sunspot emerge unexpectedly. This sunspot is large and active. These observations tell us that the sun is full of surprises. They also suggest that the sun is heading towards a strong solar maximum. This solar maximum could have significant effects on Earth. NASA has a spacecraft studying the sun. It is called the Parker Solar Probe. This probe is flying closer to the sun than any spacecraft before. The Parker Solar Probe is collecting valuable data. This data is helping scientists understand solar activity. It is also helping them learn more about coronal heating. The Parker Solar Probe is a crucial part of our efforts to understand the sun. Its mission is dangerous, but it is providing us with incredible insights. This information will help us predict and prepare for future solar maximums. Section 5. Earth's shield. Impacts on our planet. Our planet is constantly under the influence of various cosmic forces, and one of the most significant is the activity of our sun. The sun, a massive ball of burning gases, plays a crucial role in shaping the environment of our solar system, including Earth. Solar maximum, a period of greatest solar activity in the 11-year solar cycle, can affect Earth in many ways. During this time, the sun exhibits increased numbers of sunspots, solar flares, and coronal mass ejections. The increased energy from the sun can disrupt our planet's magnetic field. This magnetic field acts as a shield, protecting us from harmful solar and cosmic radiation. When it is disturbed, it can lead to a cascade of effects on Earth. One of the most immediate impacts is on our satellites. These disruptions can cause malfunctions in satellite operations, affecting everything from GPS navigation to weather forecasting. It can also disrupt communication systems and power grids. High-frequency radio communications can be blacked out, and power grids can experience surges and outages, leading to widespread consequences for modern infrastructure. On a more visually stunning note, solar maximum can also lead to more intense auroras. These natural light displays, known as the northern and southern lights, are a direct result of solar particles colliding with Earth's atmosphere. Auroras are beautiful light shows in the sky, often seen in polar regions. They are not just a visual spectacle, but also a reminder of the dynamic interactions between the sun and our planet. They are caused by charged particles from the sun interacting with Earth's atmosphere. These particles are funneled by Earth's magnetic field towards the poles, where they excite atmospheric gases, creating the vibrant colors of the auroras. The effects of solar maximum on Earth's climate are still being studied. While the sun's activity does influence our climate, the extent and mechanisms of this influence are complex and not fully understood. Some scientists believe that solar activity could have a small influence on our planet's temperature. This influence is thought to be minor compared to other factors, but it is an area of active research. However, the main driver of climate change is human activity, particularly the emission of greenhouse gases. These emissions trap heat in the atmosphere, leading to global warming and a host of other environmental changes. Understanding the interplay between solar activity and human impact is crucial for predicting and mitigating future climate scenarios. Section 6. Navigating the storm space missions and solar weather. Space weather is a term used to describe the conditions in space. Solar maximum can create hazardous space weather. This is a concern for space missions and astronauts. The increased radiation from the sun can be dangerous to astronauts. It can also damage spacecraft electronics. Space agencies carefully monitor space weather. They adjust mission plans as needed to protect astronauts and spacecraft. Understanding and predicting solar weather is crucial for the future of space exploration. As we venture farther from Earth, we need to be prepared for the challenges of the space environment. Section 7. A History of Cycles. Understanding the Sun's Rhythm. The Sun, our closest star, has fascinated humanity for millennia. Its cycles of activity and dormancy have profound effects on our planet, influencing everything from climate patterns to technological systems. Scientists have been tracking solar cycles for centuries. Early astronomers, using rudimentary telescopes, first noticed the appearance and disappearance of sunspots on the Sun's surface. These dark spots, which are cooler areas on the Sun, became key indicators of solar activity. We have records of sunspot activity going back to the 1600s. These early observations were meticulously recorded in astronomical charts and drawings, providing a valuable historical archive of solar behavior. These records show that the Sun's cycles are not always the same. Over the centuries, scientists have noticed variations in the intensity and duration of these cycles. Some periods are marked by numerous sunspots while others are relatively quiet. Some cycles are stronger than others. This means that during certain cycles the Sun exhibits more intense activity, with larger and more frequent sunspots, solar flares, and other phenomena. Some cycles are shorter or longer than average. The typical solar cycle lasts about 11 years, but this can vary. Understanding these variations is crucial for predicting future solar behavior. The previous solar cycle, cycle 24, was unusual. Unlike most cycles, it did not follow the expected pattern of a single peak in activity. It had a double peak. This means that instead of one period of maximum solar activity, there were two distinct peaks, separated by a period of lower activity. This means that there were two periods of heightened solar activity. Such anomalies can have significant implications for space weather and its impact on Earth. Scientists are studying past solar cycles to understand the current cycle better. By analyzing historical data, they can identify patterns and trends that might help predict future solar behavior. They are looking for patterns and clues. This involves using advanced computer models to simulate solar activity and compare it with historical records. This information can help us predict what to expect from the Sun in the future. Accurate predictions of solar activity are essential for preparing for potential impacts on our technology, climate, and even human health. Section 8. Unlocking the Sun's Secrets. The Importance of Research. The Sun is a fascinating and complex object. The more we study it, the more we realize how much we still don't know. Ongoing research is essential. We need to improve our understanding of solar cycles. We need to develop better tools for predicting solar activity. This knowledge will help us protect our technology. It will also help us explore space safely. The Sun is the center of our solar system. It is a source of life and energy. By unlocking its secrets, we gain a deeper understanding of our place in the cosmos. Section 9. Conclusion: the Sun's unpredictable nature. The Sun is a dynamic and ever-changing star. Predicting its behavior is a challenge. While we have learned a lot about solar cycles, they can still surprise us. The current cycle is a good example. The Sun has been more active than some predictions suggested. This reminds us of the importance of ongoing research and observation. As we continue to study the Sun, we will unravel more of its mysteries, and we will be better equipped to live with our nearest star.